Okay, earlier we graphed this function f of x equals x squared minus 3x. So this is the graph. We graph this using the roots of the function, the vertex of the function, and we use it to make table of values for f. Now, we will be solving for the slope of the tangent line at x equals 2. But before we solve the slope, we need to see first how does this tangent line look like at x equals 2. So, let's try to make a tangent line. So, look like, okay, like this. No? So, it's like, yeah, so this is the slope, the tangent line. So, the tangent line at x equals 2. Now, what if we are going to estimate the slope? No? Suppose we are going to estimate what is the slope of this tangent line. By visual observation, we may find the slope of this line. No? So what we will do is just take points in the tangent line. So for example, we take this point and this point here. So we can solve for the slope, right? Using the formula, m equals y sub 2 over x sub 2 minus x sub 1. So we can use that formula to find the slope of the tangent line. So it's like, okay, so if we take this point, for example, what's the coordinate of that point? 1, 2, 3, 4. No? So the coordinate of the point, this point, you have 4, 0. And then of course, you know this point, this is 2, negative 2. So we can solve for the slope basically. So we may take this one as x sub 2, y sub 2, x sub 1, y sub 1. So y sub 2 equal to 0 minus y sub 1, which is negative 2, all over x sub 2, which is 4, minus 2. So that's equal to 2 over 2, or that is just 1. So without using calculus yet, you are able to find the slope of the tangent line at x equals 2. The slope of the tangent line at x equals 2 is 1. So therefore, you can answer this. The answer is 1. The slope of the tangent line is just equal to 1. Simple. But in some cases, you know, where the graph is not as simple as this, it may be really difficult to find the slope directly by using this procedure. And that's the time that our concept of limit comes in. So we will look for another way in finding the slope 1 using the idea of limit. So of course there is one procedure, that is by drawing accurately a tangent line, and we use this procedure to find the slope of the tangent line. Now we will be using the idea of calculus in finding the slope of this tangent line. So how is the idea of limit used here? Okay, so first, if you have, for example, points here. No? So suppose these are points. You take one point here, so that you have a second line. So you extend it there. No? We fix it, and then we make this point nearer. So we make this point nearer. It's like this. We make this point nearer to x equals 2. Okay. So eventually, if you are making this point here move nearer to x equals 2, it's like you are already duplicating the tangent line. So it's like you fix that point here, you fix it here, then you move gradually to that to this point. So you are able to duplicate, no, or superimpose the tangent line. So that's the idea. What we will do is to get some points here, and then we will just make the distance between 2 and this point here on the x-axis here approach to 0 or very near to 0. Now let's take for example a point here. We take a point here. Okay. Arbitrary point, not this point x equals 1, but let's say some other point here. Let's say this is x equals b. So this is b here. What is the coordinate of this point where it intersects with x equals b? So it has the coordinate b and f of b. Okay, so this is the coordinate of this point. Okay. Now let's try to magnify this part here. Okay, on the x-axis that is b, and then this is 2. Okay. So let's try to magnify that part. So suppose this is b. Yeah, this is b. And then the other one here is 2. Just magnify it. So you have here then your graph looks like okay, this is below it is the graph now. So your graph would look like this b. So it's like your graph is going that way. Okay, this part here, this small part, it's like this part. Okay. Suppose this distance is h. Suppose that distance is h. Can you express b in terms of 2 and h? Of course, yes. The answer is yes. Because if you add b plus this distance h, the result is 2, right? So therefore, b can be written as 2 minus h. Okay, so b can be written as 2 minus h. So what will happen here? We can substitute b, no? We can substitute b to, we use now 2 minus h, comma, f of 2 minus h. Okay. So, using the slope of the tangent line, so we have 2 points here, 2 minus h and f of 2 minus h and 2 negative 2. So we will try to solve for the slope of the tangent line. Okay. So consider it to be our x sub 2, y sub 2, x sub 1, y sub 1. X sub 2, f of 2 minus h minus y sub 1, negative 2. All over 2 minus h minus 2. Okay. Now, we solve for f of 2 minus h. Of course, f of x is x squared minus 3x. So therefore, f of 2 minus h is just equal to 2 minus h squared minus 3 times 2 minus h. Okay? So we write it here. 2 minus h squared minus 3 times 2 minus h. Negative 2 minus negative 2, that's plus 2. So you'll be left with 2 minus 2 is 0, so that's negative h. So, of course, we can expand it as 4 plus 4 minus 4h plus h squared minus 6 plus 3h plus 2 all over negative h. So, what is left is 4 minus 6, that's negative 2, plus 2, that's 0. And then you have negative 4h plus 3h, so that's negative h plus h squared all over negative h. Okay, so this is equal to, you can factor out negative h, you'll be left with 1 plus 1 minus h. Because when you multiply it, negative h times 1 is negative h. Negative h times negative h, so it's positive h squared over negative h. And this is just 1. So you have 1 minus h. Okay, so this is the slope. The slope of the tangent, or the slope of the second line. So where is that second line? This second line. The slope of the second line, that one, is just 1 and 1 minus h. So it will just depend on the value of h. Now what happened to the value of n? Okay, what happened? If you look at this expression, as h is very small, as h approaches to 0, as this h approaches to 0, what will happen to the value of m? As h is approaching to 0, no? 1 minus 0.00 something, what will happen to the value of m? What will happen to the value of m? M will also approach to a certain value. It's like substituting 0 here. So m will approach to 1. So what does that mean here? If you allow this h, that's the distance between 2 and b, h, if you allow that h value to be very small, so what will happen is the slope of the second line, will eventually become the slope of the tangent line. So what happened here? That the second lines that you are drawing from the left of 2, as you make that point very near to this point, our point of concern, x equals 2, that will eventually become what? The tangent line. And what is the slope of the tangent line? The slope of the tangent line is 1. So our answer earlier, 1, and this value coincides. Okay?